Welcome back. We're going to continue our discussion this time around on molecular geometry, and the procedure I showed you for electron geometry is exactly the same. Only difference is we're using a different table. So some of the decrypted codes have same names, but some have slightly different names. It's your best interest to go compare the tables, see where they are different, although it's not required. So let's get started. So we have NCl3 is our compound, and nitrogen is 5A, and chlorine again is 7A. So nitrogen has 5 electrons. Each chlorine has 7, but we have 3 chlorine, so 7 times 3 is 21 electrons, a total of 26 electrons. So the element that's least in count goes at the center. We have 5 electrons, so just put them 5 around it. And then put the 3 Cls around it. Okay. And use 1 electron from each chlorine to bond with 1 electron on the nitrogen. That means each chlorine is now left with 6. So split them as pairs and draw them. Now what you see is the central element is A. We only have 1. We have 3 outer elements, so 3, so AX3. But out of the 5, only 3 electrons on the nitrogen has been used. 2 remain unused, right? Which is this. And that's called a lone pair. That's what I was referring to as lone pair on the central atom. We have 1 pair, right? On the central atom. We have only 1 pair, so 1E. If you had 2 pair, then you write E2. You have 3 pair, then you write E3. But we only have 1 pair, so that's AX3E, and that would be trigonal pyramidal, right? And what did I say? As a general rule, if your molecule contains E, it's polar. You don't believe me? Go ahead and try for H2O. And figure out what it is. Just practice, you know. In addition to what I'm going to give you, this is an extra problem. Start practicing for H2O. Let's do it for BCl3. Boron is 3A, and chlorine is 7A. So each boron is 3 electrons. A chlorine is 7. We got 3. So 7 times 3 is 21, and the net of 24 electrons. So we'll go ahead and put the boron and put the 3 electrons around and start positioning your chlorine where you're located the 3 electrons, and use 1 electron on each chlorine to pair with 1 electron on that boron, which means we are left with 3 pairs on each chlorine. Well, we have 1 central atom, 3 outer atom. There are no electrons left on the boron. We used them all up. There's no pair or no electron left. So this is AX3, which is trigonal planar, and you predicted right. Is this polar or nonpolar? The answer is nonpolar. There you go. So I'm going to do 1 out of this practice problems, and you're going to attempt the rest. Okay, I'm going to skip this one and give you I'm not going to do this one. I'll give you a different one to try. So okay, try this one, because that's not something I meant to ask you. So I'm going to try this one. So xenon is 8A. Okay, and fluorine again is 7A. Okay, but so we have xenon is 8 electrons. We got 4 fluorines. So 4 times 7 is 28. So we have a total of 36 electrons. Xenon is least in count, so put it at the center. Start putting the 8 around it. 4, 5, 6, 7, 8. And start positioning your 4 fluorines around. It doesn't matter where you put them. Just position them in such a way. So I'm going to pair 1 electron from fluorine with 1 electron on the xenon, which means I'm left with 6 more electrons on each fluorine. So split them as pairs of 3, just like how we've been doing so far. Again, there's only so many compounds I can ask you. Now what do we have? We have 1 central atom, 4 outer atom. We're left with 4 electrons. We can split them as pairs of 2, which means AX4E2. And if we go back to the table, now it's important, you have to know what I want. What if I want the electron geometry? Well, go back to the table. AX4E2 electron geometry is square planar. I would be very specific on what I want you to do. And as far as polarity, it doesn't matter. We got E, so it's polar. And that's it. So go ahead and practice these two. And once you get comfortable with this, then you have pretty much learned the idea of VS, EPR, and Lewis structures. So I'll see you with another concept. Stay tuned.